Question 20. Find all the values of theta where theta is greater than or equal to 0 degrees and less than or equal to 360 degrees, such that sine theta minus 60 degrees is equal to negative the square root of 3 over 2. Let's have a look at the trigonometric equation. We have the sine of an angle, which is theta minus 60 degrees, is equal to a negative ratio. Now, because the ratio is negative, that means the angle theta minus 60 degrees must lie in either quadrants 3 or 4. And that's from all stations to central. That is, sine is negative in quadrants 3 or 4. The next step is to isolate theta minus 60 degrees. We need to cancel out the sine operation here by taking the inverse sine of both sides of this equation. So effectively, what we're doing is moving this sine over to the other side and it becomes inverse sine. On your calculator, usually that's shift sine. So theta minus 60 degrees is equal to the inverse sine of negative root 3 over 2. And that gives us two angles. It could either be 240 degrees or 300 degrees. Another way to work this out is to work out the inverse sine of positive root 3 over 2. And in that case, you'll get 60 degrees. Then we need to move that angle from quadrant 1 to its equivalent angle in quadrants 3 or 4. So if it's in quadrant 3, we take 180 degrees, add it to 60 degrees, and we get 240 degrees. And if it's in quadrant 4, we start off with 360 degrees and then take away 60 degrees. And that's how we end up with these two angles, 240 degrees and 300 degrees. Now, adding 60 degrees to both of these angles to make theta the subject, we get theta is equal to 300 degrees or 360 degrees. But there's still one more angle that's missing from the solution. If we go back to the interval, theta is defined between 0 degrees and 360 degrees inclusive of the endpoints. Another thing to note is that the period of this trigonometric function here is 360 degrees. What that means is that these solutions will repeat themselves every 360 degrees. So in other words, if we take 360 degrees here, that's one of the solutions, take away 360 degrees. So in other words, go back 360 degrees, you get 0 degrees. And that's another solution. And I've noted that here. So sine of 360 degrees is equal to sine of 0 degrees. And 0 degrees is included in the interval. Therefore, theta is equal to 0 degrees, 300 degrees, or 360 degrees. Further note, let's say for argument's sake that the question is asked where the domain is not specified. In other words, we're dealing with an unrestricted domain. What would the solution look like then? Now, if the domain is not specified, the solutions for theta greater than or equal to 0 degrees and less than or equal to 360 degrees, in other words, these three values here, will repeat every 360 degrees, since the function sine theta minus 60 degrees is a periodic function for starters, which means it'll repeat itself over and over again forever, and it has a period of 360 degrees. So in this case, the solution follows this pattern. We start off with our original three values for theta in the interval 0 degrees to 360 degrees, but then we add 360 degrees to these three values to give us these three values here. We'll get 360 degrees, which is just a repeat of this value here. We'll get 630 degrees here and 720 degrees here. And the pattern will continue forever in this way. It'll also continue forever in the negative direction as well, but that is not shown here.